Hey, Nick Hancock here with Aerial Elite Solutions out of Central Illinois, and we are up in Fulton, Illinois today. With the goal is to perform a standard solar panel inspection with Raptor, using Raptor maps, the standard flight, which there's an overview, a standard, and a comprehensive. There are different levels of detail, different altitudes, different information gathered and captured. But yeah, so we're going to do a standard today, and I don't know if it's going to happen or not. There was a storm front moved in early this morning, which no big deal, but it looks like it's just really lingering, and that doesn't mean anything, I guess. We'll get to the site here in a few minutes. I'll get the irradiance meter out and we'll see where we're at, because yeah, the panels have to be getting hit by some pretty good sunlight in order to be cranked up and working how they need to be for us to see what we need to see. So yeah, it is called Cattail Solar, and yeah, it's a 3 megawatt farm, and yeah, we'll see how it goes. Should be good. Well, we made it to the site here, which I don't think we ever thought that would be an issue in the first place, so that's not really much of an accomplishment. However, it is the first step, is getting here. So I know for sure we're not there yet. It's still 9 o'clock in the morning, so we have an hour before it will be time to do anything at all. Oh, I'm really close, huh? I'm just trying to see where the sun is at. See, it's tucked behind them clouds. We got quite a ways to go, which, again, 9 in the morning no matter what. You're not going to get a read. And if you can see right now, because so these solar panels, as the sun moves, as it comes up, it's poking out of the clouds over here trying to, you see those solar panels are facing that way. So they're facing to the east, and they're running north and south. Well, what's going to happen is, as the sun starts moving overhead, those panels are going to tilt and follow the sun. Yeah, so around noon they'll be facing straight up in the air. Usually you can get, if the sun is how it needs to be, between 10 o'clock and 2 o'clock is when we're in a position where the panels are in a position where the Raptor maps data can be collected, just because I think it's just a matter of the sun being to where the panels are pointing that direction. The irradiance meter is because what it does is it tells us the irradiance reading of the sun, the same as it would be for the panels. So typically it'd be good to get right up next to the panels. However, this isn't an issue at all, because I'm literally probably 10 meters tops, maybe 6 meters from the panels. So I'm at the same area and angle it won't be a problem. But the key is going to be getting it set up and actually being able to fly. So what we're going to do here for an hour, I am going to get a couple things set up still, and I'm going to look at the weather map a little bit, see what the cloud coverage forecast is currently, because it seems to change very frequently. And yeah, we're going to see if we can't get this thing up in the air. This right here is where we'll be launching from. We'll pick a spot. I don't mind that it rained because now it's not all dusty. Because that's the one thing about the M300 is those props, they get to blowing, and they blow. So you either have to have a substantial landing pad, or just know how to land, which that usually works out best. So, all right, we're gonna get back with you here momentarily. I'm gonna go, I'm gonna look at this weather map. Hey, good morning, everyone. Nick Hancock here with Aerial Elite Solutions. We are at Cattail Solar Farm. It's a 3 megawatt solar farm, and we're out here today, and we're gonna do a Raptor Maps standard flight. For those of you who are familiar, there are 3 different options when you're doing Raptor Maps flight: the standard, and then you have the comprehensive, and then just the overview. So we're gonna be doing the standard today. Of course, everything is dependent upon the sun. So we're going to see if the irradiance meter is going to let us do it. And it looks like it is. We are 880 watts per meter squared. So what that means is anything over 600 and the panels are working hard enough for us to be able to get our data. So what we're going to do now is reading well. We are going to go ahead and get the M300 set up with the H20T, and we're going to rock and roll and get us a flight going. There's 2 flights we have to do. We'll do an oblique flight as well as a ortho flight. So yeah, let's get it. Here is the money ball right here. The Zenmuse H20T. Let's put it before we mess with it on the aircraft. Legs down, lock it. So fortunately, we have rain. So benefit there is that it's not super dusty. So we don't need to even worry about a landing pad or takeoff pad or whatever. Because those of you who have seen one of these suckers operate know that there is definitely no shortage of dust getting kicked up with the M300. All right, so here's where we're at now. We are, we're checked in. So let's go with flight routes. And we already have this flight route created. And so all we're gonna have to do after we put put the gimbal in free mode, all we will have to do is hit go. And so the controller takes us through just information, basically. Loss of action, signal loss. This is return to home, and I want it to hover. Yeah, I think we're good everywhere else. Next. Oh, it's telling us, so in Raptor maps, they do not require a significant overlap. So it warns you in case you're trying to do mapping mission. Yeah. So we'll upload the flight mission. Let's go. Let's get this puppy strapped on here. It's warm. And from here, we should be
moving to start point.
Well, conveniently enough, we got here and got this done in what would appear to have been the hour it's going to be sunny all day. So timing was good for us. And if you have any questions, if you are a solar inspector, solar field inspector, or you're trying to be, there's several different aircrafts you can use. Raptor Maps is just got the industry cornered right now, and they're doing great things. So that'll be a good platform to use. Of course, the quality of payload is essential. So it is not going to be cheap to inspect solar, but I tell you what, if you get in the plug with the right people and the right connection or whatever, it's very awesome and profitable gig. Just because, if for no other reason, because of the amount of time and money you're saving the owners of these solar fields. The time and money you're saving them is just incredible. 3 guys for a solid work week going around with handheld thermal cameras reading out each of the panels. It would take a week for 3 technicians to do that. I just did it in about 40 minutes, and I would say, if my signal strength was better, it kind of just depends on where you're at, but by the end of the day, at the latest, all of the data will be uploaded, and the information should be able to be passed along. So it all works out, man. It's a great industry, great time to be a drone pilot. If you have any questions or any curiosities, feel free to hit me up or leave a comment or whatever you want. Appreciate you. Fly safe.